Hey everyone, this is Satish Hooli, Department of Civil Engineering, VSMIT Engineering College, Nipani. So today we are going to see the topic with the subject WSTE on sedimentation. So these are the topics that will be covered. Okay. So first one is in sedimentation theory, type of settling, type of sedimentation tank. So now what do you mean by sedimentation time? What do you mean by sedimentation? So sedimentation is nothing but you tend to remove suspended particles which are present in water. These are also called known as in clarification. So it means what key you are removing and suspended solids. Okay. And this type of basins are also called as in special basins or in settling tanks. The main objective here is nothing but to remove suspended matters, okay, from water in a purification process. So normally in a purification process, it comes under an primary treatment, and it is after an screen chamber or a grid chamber, just before an aeration tank or in filtration unit. Okay, which and what it does, it tend to remove the impurities, okay, suspended solids which are present in the water, and by doing so what it does, it tend to remove much of the load from that treatment process. Okay, BOD is being reduced. Okay, and the treatment process is quite effective. Okay, there are three forces acting in an sedimentation process, or you can say it is an sedimentation forces also. Okay, so this is also known as theory of sedimentation. The first two forces are velocity and shape and size of the particles. So you can control the velocity with the help of an velocity regulators, or you can say flow regulators. Shape and size can be changed by adding some chemicals in a sedimentation tank, and you can control it, and which will help you to settle down those impurities which are present in the water itself. Okay. The third one is in viscosity. So viscosity, as you know that it's in directly proportional to the temperature. So it cannot be controlled very much easily, and practically also it is not possible to control it. So what we do, we leave it uncontrolled. You are not going to try, you are not going to control it. Okay, next one, principle of settling. So principle of settling is nothing but what happens here is, as we know, as you know that suspended particles have a specific gravity greater than that of water. So what we do is, under the action of gravity, you tend to settle down these particles. Okay, and the turbulence here is retarded by offering and storage. So what simple demonstration of this is nothing but take a bucket, pour the water, put some suspended particles, put some impurities in that like mud and all, throw it. So that bucket is nothing but it's an offering and storage, and those particles which have been thrown in that bucket itself. Okay, they do have a specific gravity that is more than that of water. So now we are offering and storage. After some times, you can see that all those particles are settled down at the bottom. So this is nothing but this is a settling taking place. Okay, and these flow retarders, okay, are also known as an settling time. So flow retarders are nothing but what you can say is you tend to reduce the flow in those basin. Okay, velocity has been reduced. Okay, so such type of basins you can call it as an settling tank. And the third one, the theoretical average time for which water is retained is in that settling tank is known as retention period. So it is the time taken for those particles from move from entry to exit. It is by simple words I can say there is that is nothing but retention period itself. For example, if you're moving from one point to another point, from one point A to B, it is nothing but in travel time. Here we can call that one as an what, detention period itself. Next one, to achieve these principles, okay, what we need to do, okay, how it is being done. In other words, in sedimentation basin, what happens, or sedimentation tank, what happens here is the velocity is being reduced. So when a velocity is being reduced, what it does, it increases a travel time, and the detention period here is of a longer time. So it's been of a longer time, okay. So naturally, whatever the sediments are present in those basins tend to settle down in sedimentation tank, okay. And what we can do, again what we can do is we can change the shape and size of the particles, or you can, what I can say is, you can alter the shape and size of the particle by adding certain chemicals. Okay, so this type of settling, or this type of sedimentation process, we call it as an sedimentation added with coagulation. So such chemicals are known as coagulants. So these coagulants are nothing but like an alum, copperas, and sodium um, aluminate, etc. Okay, and this process is quite effective, where we can settle down fine and very fine colloidal particles. Okay, when we are not adding any chemicals, okay, to this sedimentation process or that sedimentation tank, okay, such type of sedimentation process, okay, it is nothing but, we can say here is, it's an plain sedimentation. Okay, under this we are not going to add any chemicals over there. This figure shows you this figure shows you a circular tank and an rectangular tank. Okay, rectangular sedimentation tank is generally made up of an reinforced concrete. It may be in rectangular or circular in plan. Okay, the capacity should be designed in such a way that high volume of suspended solids can be settled in that tank itself. And in plain sedimentation, nearly 70% of suspended particles or impurities which are present in water can be removed very much easily. The type of sedimentation tank, the type of settling tank, nearly there are mainly divided into two types. One is an horizontal flow tank, one is a vertical upflow tank. In horizontal tank, we have got a rectangular tank with an horizontal flow and a circular tank with an radial flow. Now, what is this rectangular tank with an longitudinal flow or an horizontal flow tank? It has got an longer rectangular basin, and it is easy to control the flow in this type of a tank. In large volume, also there is a slope provided at the bottom, okay, in such a way that whatever the sludge which is present in water or impurities which is present in water, it moves towards that hopper, and from that hopper there is a pump which is pumps that sludge or impurities periodically or continuously without stopping the process. This tank can be used as in periodically, or it can be used continuously. I am meant to say is batch wise, or you can use it continuously. There are four zones in it. One is an inlet, one is an outlet, one is an inlet mechanism zone, one is an outlet mechanism zone. Okay. Next one. Next one is an tank with an radial flow. It also comes under an horizontal flow. Horizontal flow. What happens here is the effluent is being pumped in the center, and then it is being distributed in the tank. Okay, with the help of bubbles, what happens here is the flow take place radially towards the perimeter. Okay, towards the and this flow is parabolic, not in a straight line. Okay, and the flow is taking place in such a way that it is going, it has, sorry, as the distance is been sorry, the velocity has been decreased, okay, as it moves from the center. Okay, so the velocity has been decreased, and it got in simple mechanisms which removes whatever the impurities are being settled down at the bottom. And this is quite effective type of n tank, and this type of n tanks are commonly used in effluent treatment plant and water treatment plant. Or in a flow tank. Okay, so this type of in tank can be used for in plain sedimentation or in combined sedimentation in flocculation. They may be square or circular in plane within hopper. Okay, a flow will in a flow type, what happens here is when the flow moves, okay, in a flow type, okay, due to increase in the cross section area, okay, there is a decrease in velocity, and the and clarified water can be drawn from the circumference or from a central weir itself. Okay. Again, when you add in chemical to this tank, or you can say when you add in coagulants to this tank, the flocculation is taking place at the bottom and it rises up the flock. Okay, so this phenomena is also known as an upflow sludge blanket clarifiers. Okay, so this is all about in vertical or a flow tank. Next one, to understand the type of settling, understand we need to understand, okay, the type of impurities. There are mainly two types. One is a discrete and angular particles. Discrete or angular particles are nothing but which do not change their shape and size. Okay, such as sand. The flocculated particles do change their shape and size. For example, clay and silt. Okay, clay and silt. Type of settling. There are mainly four types. The first one refers to in discrete particles, okay, with dilute concentration. Next one is second type is nothing but flocculated particles with rare dilute suspension. The third one is in zoned settling involved in flocculated particles with concentrated suspension. The fourth one is in sludge blanket, which is in wastewater treatment. Okay, so this usually represents the fourth one. So here in this graph, you can say here is a lower concentration of solid, higher concentration of solid particulates and flocculated. So type 1 always lies with respect to lower solid, okay, and particle matters. So type 2 we can see here is it has gotten a lower in concentration, but it also has a little bit in flocculated particles. In third type, okay, it is got a little bit higher concentration of solids and it has got an flocculated type. Next, okay, the fourth one is more towards a higher concentration of solids and towards an flocculated particles. Here that one is being represented. This is the fourth, this is the fourth, this is the third, this is a this is sorry, this is in second, this is in first one type. So you can see there is a less solids over here, little bit more solid, little bit more solid, and there is a higher concentration of solids over here. And this can be also, the settling can be also represented with respect to depth and time. Okay, as you can see in this what can I say, um, the this one discrete particles will take less time to settle than those often flocculated type, okay, or in compressed type itself. Okay, This is a graph which is presenting in depth versus time over here. Next one. Segmentation times are designed on the basis of certain assumptions. So what are these assumptions? So first assumption is here is nothing but what we can say here is the particle and their velocity vector is equally distributed. Means those velocity vector is equally distributed all across that tank itself. The next one what you can say here is the liquid which is there in that it moves, okay, um, whole length of that tank itself. Okay, the third one what you can say is the hinting particles will settle down at the bottom of tank and then they are being removed out. So these are the some assumptions which we need to make when you tend to design a sedimentation tank itself. There are certain design elements of sedimentation tank. The first one is in retention period, okay, or you can say and in displacement. Second one is in flow rate. Third one is in basin dimension. Fourth one is an inlet and outlet arrangement. Fifth one is a sludge removal device. So now detention period and the displacement. So it is nothing but theoretical time taken of particle from passes between entry and exit. So it can be written as denote volume by discharge. We take in detention period around 4 to 8. Next one, flow rate period. So flow rate period is nothing but it's an average requirement of a batch, okay, that passes through the settling, and it is always less than that of an detention period itself. Okay, so okay, it can be and this one the ratio of the flow of detention period and detention time is also called as an displacement efficiency, and the value should be in between 0.25 to 0.5 in plain sedimentation. So this is nothing but nu d equals to flowing through period divided by detention period itself. Okay, so this is of flowing through period. Next one, flowing rate of surface loading. So this is nothing but how much quantity of water you are adding per horizontal area. Okay, so this is known as surface loading. So it is given by Vs equals to Q by A. So it is expressed liters per day per meter square. Okay, and these are the expressions of those. Next one is nothing but basin dimensions. So basin dimensions are nothing but they are being determined by how much quantity you are loading. Loading means what? Much quantity of wastewater or water you are loading in that sedimentation tank. Okay, so sedimentation tank surface area is given as A equals to volume of water in liters per hour divided by surface loading area in liters per hour per meter square. Okay, so these are again certain assumptions what we can make it here. The length width ratio of a rectangular tank should be in between 3:1 and 2:5:1. Okay, and depth of the basin should be kept in between 2.5 to 5 meters. Horizontal flow should be in between 0.2 to 0.4 meters per minute. Okay, and slope of the hopper should be in between with respect to vertical and height 1.2:1 and 2:1. Okay. So these are the dimensions. Inlet and outlet arrangement. So inlet and outlet arrangement should be in such a way that there should be a minimum disturbance taking place. So there is a high turbidity in that. So if there is a disturbance, what happens? There is an eddy current that will be going over there, and which creates what it creates. It creates a black flow. So what happens at here? It might be okay. So if there is an inlet and outlet here, there is a black flow which might be created over here. Okay. Again, here there are certain assumptions. Okay, sorry. An ideal structure should be. So how inlet and arrangement should be. How the ideal inlet and arrangement should be. Okay. So the first one, uniformly distribution of water as far as possible across the width and depth of the tank. So there should be an uniformly distribution. Next one. Okay. The mix with the water is ready in the tank to prevent denser current. So the mix should be here, should be ready itself. Okay. Next one, there should be a minimum turbulence over here. Okay. The fourth one, you should achieve a maximum longitudinal flow or a radial flow over here to achieve high amount of efficiency. And the velocity should be ranged in between 0.2 meter per second to 0.3 meter per second. Next one is an outlet arrangement. Okay, so outlet arrangement here, it consists of a notch or a weir. You can see here itself. It consists of a notch or a weir itself here. Okay, so notches, especially we tend to use a V notch of in a minimum placed in between 150 to 350 mm center to center with buffers provided. Okay, so this is an outlet arrangement. So this concludes my. So you have cleared, I cleared most of your doubts, and if there are any doubts, you can contact me. Okay, so next part we will see with respect to sedimentation with added coagulation. Okay, so thank you.